Welcome students. Today we are going to have a discussion about the important technique in chromatography after HPLC. This is about HPTLC, especially this one in this topic and also in herbal standardization and herbal formulation, identification of phytoconstituents. This chromatography technique, HPTLC, high performance thin layer chromatography, which is having related with thin layer chromatography as well as performance. Even you are giving the solvent system in such a way, it is an interesting technique which has an even pressurized also can be applied, giving some active movement of the mobile solvent can be done as we did in high performance liquid chromatography is also possible in this high performance thin layer chromatography. So listen to the class and the video also I have just added to see the application or the usage of the HPTLC, how it can be performed. So it will be more useful for B.Pharm students and even research students, M.Pharm students. So kindly make use of this HPTLC class. HPTLC is high performance thin layer chromatography. This is the instrument. This is a picture of the instrument present in the lab with an exhaust, and also you can see there the developing chambers, detecting chambers with UV detectors, which is connected with an system, a computer system. With the AI technology, it is possible for you to identify the constituents, and it will be able for you to design even various drug in the formulations. High performance thin layer chromatography, that is HPTLC, is a powerful analytical technique which is wonderfully suitable for quantitative and as well as qualitative. I mentioned qualitative and quantitative analytical task. The development of chromatographic fingerprinting plays an important role in the quality control of complex herbal medicines. Complex herbal medicines is an important task for the herbal formulation manufacturers and even users, consumers also. It's an important thing which has to be noted actually by WHO also insist about knowing the multi-drug formulations, about its therapeutic activity and its constituents doses are very, very important to know about safety and efficacy of a herbal drug usage. First here we should know about the selection of chromatographic layer. Already the student may be knowing about the definition of chromatography because we have seen about thin layer chromatography, paper chromatography, advanced HPLC also. So it will be easy for you to remember these type of words and also to revise your previous knowledge which you have about chromatography. Selection of chromatographic layer, because this is thin layer high performance chromatography. So you can see there is what type of layer, what is the size of the particles. These all have a major role in the separation of the mixture of compound. So first one is preconditioning. We should know what is preconditioning. All students should remember preconditioning means what we did in the paper chromatography and in thin layer chromatography in the lab. Saturation. We did saturation with the mobile solvent in the developing chamber so that you can avoid the edging effect of the solvent front. So these complications can be avoided when you are using saturation or when you are following saturating the chamber which you are using for chromatographic development. The second one you should know pre-washing. This is not done there, but here it is possible in HPTLC. Pre-washing means suppose there is lot of dirts, impurities may be present in the stationary phase itself. So that it is possible for you to pre-washing can be performed in the thin layer of plate by running with solvent methanol. The high polar solvent can remove any type of impurities which may be present in the thin layer which is already prepared, ready for our experiment. So pre-washing can be done. And next you can see conditioning. After pre-washing, you should make condition ready for the thin layer to perform your chromatographic technique. So what is conditioning? That is activation. How you do will activation? Because we want to remove the solvent which may be present in the thin layer, which will hinder our experiment. So it should be completely removed by using 105 degrees centigrade for 30 minutes in hot air oven. We can activate the thin layer chromatography for this HPTLC performance. So when you are normal thin layer chromatography and HPTLC, we are performing more sophistically, more minute analytical technique, this one. So we have to perform preconditioning of the plates or preconditioning of the experiment with saturation in the developing chamber, pre-washing using methanol. If there is any debris or impurities, dust which may be present in the stationary phase thin layer can be removed by a methanol solvent, high polar solvent. And then you can go for conditioning the plate which is ready for your experiment by activating using the hot air oven in a temperature of 105 degrees centigrade for 30 minutes. Mean particle size of HPTLC is 5 to 6 micrometer or micron compared to 10 to 12 micron in classic TLC. But in classic TLC it is little more larger actually. But when you see the layer thickness is 100 to 200 micron in HPTLC, but you can see that 250 micron in TLC. So thickness, we are talking about the thickness and the particle size. Particle size of the granules or the material which you are using for the preparation of thin layer in HPLC or HPTLC is very small, 5 to 6. But in normal TLC is 10 to 12. Thickness also you see very thin, very thin. That is 100 to 200 micrometer only, the thin. But in normal TLC it up to go to 250. In preparative TLC still more. The relative humidity plays a critical role in reproduce the result. To avoid such variation, it is desirable to preconditioning, saturation. This is what I told. Preconditioning. What you are doing? Saturate the TLC chamber with a vapor of mobile phase. The TLC chamber. That is preconditioning, which we seen in the last, just I told in the last slide. Preconditioning is more required with high polar mobile phase when you are using, and the environment of the lab contains various dust particles, vapors of various gases which can be deposited on your TLC plate. So we need pre-washing. How to perform this pre-washing? This impurity can be removed by pre-washing of the plate. Run the methanol or such other solvent without applying the sample, only the plate of the HPTLC plate, so that all dust or impurities on the HPTLC plate will be collected on the upper edge of the plate and it can be removed. Now conditioning, this also I told, after pre-washing, the plates needed activation. The plates are kept in hot air oven for 15 to 20 minutes in 120 degrees centigrade, which is known as conditioning or activation, which we did. We did there for 105 degrees centigrade for 30 minutes. Here you can keep for 15 to 20 minutes at 120 degrees, which is known as conditioning, activation of the thin layer plate or high performance thin layer plate. Stationary phase, silica gel, alumina also can be used, aluminium, TLC plates and solvents. If you want to talk about, silica gel is the most popular stationary phase, which we perform silica gel G in the normal TLC. Gypsum is needed for them to have a binder to make a thin layer in the supportive glass plate. Here we can use even aluminium foil. Ready-made thin plates are available and it is given along with the instrument of HPTLC. The most popular stationary phase is silica gel used in HPTLC. Afterwards, even cellulose initially can also be used. Homemade sheets, plates shows bigger particles. The particle size is more than even 10 micron and not shown homogeneous. It is not homogeneous. So it is not suitable for HPTLC analysis or in the lab made. Pre-coated ready-made HPTLC plates which are available in the market are more appropriate for HPTLC analysis. Plastic sheets coated also available. Aluminium foil supported HPTLC plates are now more popular compared to glass plate, which is easy actually support, which is because they are very easily cut into desirable size, as well as it is required less space to accommodate and to keep in the lab. But glass is more resistant to certain chemicals, heat and chemical reaction compared to aluminium and plastic sheets. So there is advantage also when you are using glass, disadvantage is also there. Mobile phase, according to, mobile phase selection is according to the substance, according to the compound, chemical nature, decided to separate we need. But the mobile phase or the solvent for HPTLC should be analytical grade, analytical pure. They should be kept in proper storage condition. Very, very important. Then next the procedure here, you have to revise what you did Just a small change may be there, but usually the same in the TLC what you did, sample preparation. You have to sample preparation, what is the solubility, and you have to select the solvent as we prepared for quinine sulfate for standard sample preparation how I did, and for amino acid what solvent. You have to select the solvent which is solubilize the sample. So application of the sample we did with capillary tube. Here also, that is, you have many system, automatic system, micropipette system, manual application of the sample. Then after applying, we also did the same thing, chromatographic development in the developing chamber. So here also the same procedure, but only the instrument is automatic and slightly sophisticated, slightly the performance is more interesting than normal thin layer chromatography. Next step, detecting the spots. Even there also we detected the spots by means of reagent spraying over, and also we know it is possible for you to go for UV light chamber. If you show, we can see the spots. If it is having fluorescent nature, it's possible for you to detect the spots. Otherwise, you should use detecting reagents to be sprayed over it. Derivatization we are not done there. Here derivatization is done. Derivatization means fixing the spots, fixing the separated compounds in the thin layer plate which you have received in the experiment, can be done by means of polyethylene glycols. Natural derivatization solutions are available. I have added that example also in this lecture. So by that, how you perform, how you fix the graph, chymograph in your pharmacology by using colophony. This also can be fixed by means of using various natural derivatization solution. Then scanning and documentation is done by usually computer. Same like how you performed the peak of the graph which is obtained, area of the peak, concentration of the substance, separated compound how much, qualitative, quantitative can be determined by means of scanning and documentation. Sample preparation, the sample should be homogeneous and respective to the entire batch. Sample should be homogeneous and not respective, representative to the entire batch. You are doing different batches, the sample with different solvent system. You may be doing two-dimensional separation. Whatever may be the sample should be the, once if you take a sample, the name, if suppose it is senna, the powder, extract, or if you are, whatever the material, it should be homogeneous and it is a representative for the whole experiment. The sample should be prepared such that analyte, that the phytochemical constituent present in the trace quantity can be detected. So, the compound which you are taking should be in such a way without impurity, first choice, and it should be in a quantity which should be detectable amount. If the sample is pure and concentrated, can be directly applied to the HPTLC plate. But if the analyte is present, less concentration, with impurities, then purification is needed, isolation of the analyte from the impurity is also needed, and interesting reagent, for example interfering reagent, if suppose it is present, that also should be removed, and concentration procedure, because we need some concentration, we need the amount of the sample required for the experiment is also should be performed before going to the chromatographic separation. Application of the sample we did in the normal TLC by means of capillary tube in the lab. In there also we can use micropipette. Here sample application usually generally 0.5 to 5 micro ml, very very small. It's not possible for using a dropper. It's not possible even by a capillary tube. Sample application in this case of spot of even 2 to 10 micro ml as a narrow band also they have kept, but sample can be applied as even manual application, very minute micro pipettes can be used. Instrumental techniques are there. Semi-automatic application in the instrument itself, in the HPTLC instrument itself it is there. Now chromatographic development, what you did in the lab, we used a beaker as our small pilot type of experiment. We used the small beaker. Here it is automatic chambers are there, different types of chambers are there, we should know about that also in HPTLC. Chromatographic development chamber, chromatographic development is another important aspect in HPTLC, high performance thin layer chromatography. Generally, glass development chambers are used in such purpose. The various development chambers which can be used for chromatographic developments are: one is flat bottom chamber, two is twin trough chamber, sandwich chamber, it is called even horizontal chamber, running the solvent in the horizontal position. Automatic development chamber, ADC, automatic development chamber. Forced flow development chamber, forced flow with pressure, forced flow chamber. Automatic multiple development chamber. When you are having different solvent system, in gradient method, increasing polarity, mixing of solvent, different solvent, if you want to have a mobile solvent automatically, as you did in HPLC, this also can be performed. Automatic multiple development chamber is also available for HPTLC. You just think about the how the development of the technology. Twin trough chamber are use less solvent, that is why twin trough chambers are used as a developer, and the linear developing chamber like a sandwich chromatogram is best method in HPTLC plate, is placed vertically, another one vertically in an appropriate chamber. The solvent is run by capillary action, usually the thin layer adsorbent which you kept in the HPTLC plate. Now we should know about what all the chambers which I told. What is this flat bottom chamber? The students should know, no? So this is the flat bottom chamber which is used for normal TLC also, but we have even for HPTLC in this form. And twin trough chamber, you can see that the trough will be having, this will be inside the instrument. There will be, you can see there is one. You see the picture very clearly. The bottom you can see there is two compartments by means of there is one upside that is not M. It just you can see the two compartment in the bottom of the flat chamber. The bottom you can see the solvent system which gives more. That means for example twin trough, the solvent required is very very minimum. And the second trough which can give vapors for saturation, and the plates pre-equilibrium or the saturation can also take place, or you can say preconditioning can be done by means of this twin trough chamber. Students can remember And sandwich chamber, you can see it is, otherwise it can be called as horizontal development or horizontal chamber also. The running of the solvent in horizontally, as shown in the picture. You can see the running of the solvent horizontally in this type of chambers. This actually sandwich chambers are designed for horizontal development, meaning of HPTLC, high performance thin layer chromatographic plates, is placed horizontally during the chromatographic process. Now ADC, everywhere they used to see ADC2 technique, ADC, automatic development chamber. This is the automatic development chamber. Inside, just you can fix the plate, automatically develop. You can see the plate, just for your vision showing, they have shown out down also. We can take automatically from there without using your hands touching on the thin layer part. For reproducible and automated HPTLC, high performance thin layer chromatography plate development, consider the CAMAG company automatic developing chamber ADC2 or the HPTLC Pro model development, which offer precise control over layer activity, chamber saturation, developing distance and drying. Everything can be handled by this automatic development chamber. So you should know that what is the ADC means, automatic developing chamber. Now the next one is forced flow development chamber, which we have given. This is also available for HPTLC. Forced flow development of HPTLC chamber means also known as over pressured layer chromatography, OPLC, uses a pressure driven system as shown in the picture to force the mobile phase through the stationary phase in the HPTLC plate, high performance thin layer chromatography plate. For faster and more efficient separation can be appeared. You can see that how it performed in HPLC, high pressure or high performance liquid chromatography also same thing. There is a pump, small pump, which can give the injector, you can inject also the band. You can see the separation which flows through the thin layer, and even it will be computerized, and you can see the recorder very clearly. You can scan and you can see the graphical appearance can be obtained. Even quantitative and also qualitative estimation can be performed in HPTLC by forced flow development chambers are also available. Automatic multiple development chamber, this I told you, you have to remember about the gradient supply of the mobile solvent, mixing of mobile solvent, giving in increasing polarity for separating the compounds, gradient method of mixture of many solvent system. So you can see the bottles which is shown here, many bottles with different solvent system, which can be made into develop as a mobile solvent in the HPTLC by automatic multiple development chamber. The CAMAG AMD, that means automatic multiple development chamber 2 system, is a cutting edge HPTLC, high performance thin layer chromatography chamber, designed for advanced gradient, different solvent gradient development, solving complex preparation challenges efficiently. AMD means you know that automated multiple development chamber. Now detecting the spots. Here detecting the spots after the developing any chromatogram, what you did in the lab for paper chromatography and thin layer chromatography. After development of any chromatogram, even for the HPTLC plates, are dried and evaluated for the following methods. Evaluation by non-destructive method. There are two. Non-destructive, destructive. Destructive means sample is not recovered. Non-destructive methods, directly visual method, if there is a spot can be identified. Evaluate by UV light. Reversible reaction like iodine vapor can also be do for spotting. Ammonia vapor can be used. This all can be reversible and you can recover the sample. Non-reversible reaction, fluorescent dye using pH indicators, wetting and dipping in some reagents, spraying technique. In non-reversible detection technique, in which the isolated constituents or the samples cannot be recovered and they are destroyed after detection. Just a general idea about these detection spots. But different reagents, you should remember, as we did in the lab for alkalides, we did for drag and draft reagent, followed by 0.1 normal molarity of molar sulfuric acid, and for ninhydrin is used for amino acid mixtures in paper chromatography. So detection reagents will differ. Derivatization we have not done in TLC or in paper chromatography. This can be done there also. Usually you can see the light. This is derivatized. After derivatization, this is before derivatization. They have given a picture you can see, in which you can see there is here 3, there is only 2 we have shown. In UV light 366 nanometer you can see very clearly after derivatization. What is derivatization? Fixing the spot using some reagent, usually polyethylene glycol and natural reagents, which will coat the thin layer and fix the slide, and you can preserve it for your record purpose. Future you can see after a month also it's possible, or 2 months, even a year also it can be preserved. The samples will not get destroyed when you are coating with polyethylene glycol or natural reagents. Even how you perform in chymograph in pharmacology to preserve using colophony and varnish also can be used. This colophony. In high performance thin layer chromatography, derivatization is a technique used to modify analytes to enhance their detectability. You have to identify in later or improve the chromatographic performance, especially for compounds that are colorless or UV inactive. In that case, you are using some derivatizing agent which can preserve and detect the color very feasibly and very promptly, which can be identified for our calculation purpose. It involves applying a reagent on the plate, either by spraying or by immersing, to react with the separated compounds and to create a detectable derivatives. Next one is scanning and documentation, in which we know that after the development of the spot, HPTLC plates are scanned at selected UV region. That means usually 254 nanometer and 366 nanometer have been used usually, and selected can be measured in the computer in the form of a peak and can be compared with the standard compound and other constituents. The obtained bands can be converted into peaks. The height of the peak, area of the peak, and the peak corresponding to the concentration of the isolated constituents with a standard can be compared. This document can be stored in the computer for further reference also, and the sample after derivatization can be kept in the slide, also can be kept safer for the documentation. You see, this is a video which I want to say how they are performing. Watch clearly. I will pass some places and make you to understand how they are performing. This is for ginkgo biloba flavonoids. See, first you can see this one. Especially you have to remember, in a step, first they started with sample preparation, preparation of the analytes, and sample application, automatically how to apply, and development, then documentation, then derivatization, then documentation again. But you should know the word sample preparation, preparation of analyte, and there is some vials and all you have to prepare, weigh and the solvent, and then it will be applied to the instrument directly, it will apply, automatic system. That is ADC, automatic development chamber, will be there in HPLC. And next, development automatically, and the documentation, your computer you have to say, and derivatization separately you have to do, and again document this compound. You can see now. See, now sample preparation. First one is sample preparation. She is weighing 100 milligram by a digital, and then adding the solvent, solubilizing, and then by means of using micro pipette, and just you see now sonification 10 minutes and centrifugation is needed. First she is doing sonification. This is sonification. That means that is ultrasonic rays will make them to solubilize, and then centrifugation should be done by 5000 RPM. That is also will be done by her. You can see here in the procedure. See, first she is keeping for ultrasonic solubility by using ultrasonic rays, and then she is using the, that is gyrator, and then to the centrifuging machine in the rotation of 5000 RPM. Then afterwards you got that supernatant liquid from the centrifuging test tube as shown in the picture. In the video I just made to pass to understand for the student. It will be removed to the vial which is kept in the floor. You can see in the table. And that is the next one is the instrument which is used for sealing the vial. The sample will be taken by this micro pipette, exactly 20 micro ml, and it will be fed into the instrument for automatically sampling will be made as a band. So now you can see, observe how it is performing. See there, she is keeping the, in one finger, one hand, taking the supernatant liquid with micro ml, 5 micro ml, and again 5 micro ml by the micro pipette, 10 micro ml she is adding, and then she keeps the aluminium cap, and it is sealed by the vial sealing clip. This is the sample is ready now. Just it is loading. Now you have to do, next step is loading and executing the vision of the CAD, that is the software which is used by the instrument, filling the sequence table, labeling all the TLC, that is HPLC plates, naming that Gingago, Bolobi, you are using Gingago. So if you are using Senna, you have to write Senna. If you are using digital, what type of sample you have taken, sample number, sample details should be written in the plate, and label the plate, capture the image. Without sample you have to capture the image first, how it is, white light transmission, and also you have to write UV light transmission. The computer will give the picture and you can save it for your sample. So now you can see that. Going to the computer, what all the, she want to make it in CAT, that is Gingago is my sample. She is installing and she is just preparing how many samples. how many of them she is using, RL1, RL2, like that. She is giving one name for Jinkaku, and it will be fed properly in the computer, and it will be, after writing in computer, as she is writing all the things, it is, and afterwards she comes to write in the plate also. See, in the plate, you see the plate size, it's not like what you did in the lab. It's a square type and kept inside. Now no sampling have done, only you are going to see the picture of the empty HPTLC plate before performing. What is there? Any dirt or there, anything? You can see. Now you are going to sample. You are going to sampling, fixing, sampling. See, for sampling you have to keep in the area where the sampling area. Already you have kept that vial which sample which we want to give the spotting over here, and then you kept here for sampling. Now you see the instrument, automatic sample, a pointed sampling you can see here when she give the command in the computer. The technology will start spotting. You see the needle and the sharp point, how automatically it makes the band over the plate which is kept inside the instrument. So the video was taken very clearly for the person to get understand how the sampling is done in HPTLC. And after sampling, the next one is you are going to rinsing before developing. How you are going to rinsing? What is this rinsing? You have to rinse, clean by using a solvent system is also there. At the same time, the developing chamber should be rinsed with methanol, cleaning, saturation is also, preconditioning is also needed. So you can see now, development in automatic development chamber 2, you have to make the control of humidity 33 degrees centigrade percentage for the reproducible, and filter paper should be kept in the back of the chamber for getting saturation, preconditioning. The twin tuff we are using, and 10 ml of developing solvent and 25 ml of developing solvent for chamber saturation. So you are using 10 ml for developing, but 25 ml you are using for, because twin trough, one trough will have the solvent system will be used for saturation. Another will be used for the development of our thin layer. So that is why it is HPTLC, high performance thin layer chromatography. See now, after bringing, you can see the filter paper behind, white color in the twin trough, and taking the 10 ml methanol for developing solvent or mobile solvent in the twin trough. Another one you are giving 25 ml for saturation. The 10 ml which you have made is in one trough. This is twin trough. As we have seen the twin trough chamber. Now keep the plate in the fix in this aluminium holder and fix it in that place where it can be hanged, as she is doing there very clearly. And close the lid, come to the computer and start developing. So this will come down the plate towards the trough, and you can see that the rising of the solvent in the plate also shown there. When it blinks, color coming to the blinking and gives the denotation, it is finished now. Green color when it comes, it is developed. Now take out, after developing how you did in the lab, now you have to go for detection. So here detection is done by, in a chamber, keeping the plate inside, white light, then next UV light, they will take a picture, in the computer it will come, and UV 360 nanometer will also, you will get the picture. And the next time derivatization, and you will do the same, and documentation. Finished. Very easy technique, very interesting technique. You can just watch here what all we have studied. See, she's keeping that plate inside, going to the computer, visualizing. By normal light, she can see that spots which is not very clear picture like this. This is normal light. And when she's made in UV light 254 nanometer, and this is UV light 366 nanometer, so prominent. And next derivatization, see, you can see this here. Derivatization means heating the slide at 100 degrees centigrade for 3 minutes, dipping in natural product reagent and dry it by air dryer, hot air, cool air, not hot air, cool air, dipping again in the polyethylene glycol 400 and drying with cool air. Then you can visualize once again, go for documentation, keep safe, keep safe. The slide will be safe for your documentation. That's what it is mentioned. That's what she was going to do now. See here, bring it with cool air, dry it and make for derivatization. Clip and fix it in the instrument. Keep the natural solution. The slide is getting dipped, you can see there. Then now dry it with cold air and again dip it in polyethylene glycol 400. And again you have to go for drying with cool air. And now you can go for visualizing in the computer in the white transmitted light and UV 360 nanometer by keeping in this instrument. You can see in the computer now more visibility, more clearly the spots can be identified. See here in the natural light after derivatization, you can see very clearly the spot. Even in 360 nanometer of UV light, you can see the colors of the spot very clearly. So this result can be repeated again. Second derivatization can also be done and you can get more clear spots. Separation of the compounds can be easily identified. This video might have given a good idea about HPTLC. Make use of it and write yourself a notes so that it will be more helpful for your studies. When you come to some example I have added because for your examination point of view, the student should know some example how to perform HPTLC. Even if they have in the lab, if you want to perform as a PG student, you need some solvent system also, like chemical compounds like polar compounds, like anthracene glycosides, arbutin, alkaloids, generally alkaloid, that is cardiac glycosides, bitter principles, flavonoids, saponins. You can use solvent system, ethyl acetate, methanol and water in the ratio of 100 is to 13.5 is to 10. Lipophilic compounds, essential oil, terpenes, coumarin, naphthoquinones, valproate. These all compounds, if you are interested to separate by HPTLC, you can use the solvent system. Toluene, ethyl acetate in the ratio of 93 is to 7. Alkaloids, suppose specifically you want to go for alkaloids. Toluene is to ethyl acetate is to diethyl amine in the ratio of 70 is to 20 is to 10. Flavonoids, you can use a solvent system of acetate is to formic acid, glacial acetic acid and water. I forgot to put the is dot in between formic acid and glacial acetic acid. 100 is to 11 is to 11 is to 26. And when you want to perform with saponins, chloroform is to glacial acetic acid, methanol is to water in the ratio of 64 is to 32 is to 12 is to 8 can be used. Cardiac glycoside, specifically if you want to perform, you can use ethyl acetate, methanol, water in the ratio of 100 is to 13.5 is to 10 or 81 is to 11 is to 8. Terpenes can also be performed with the solvent system, mobile solvent as chloroform is to methanol and water 65 is to 25 is to 4. Triterpenes can also be performed with the mobile solvent system by ethyl acetate, toluene and formic acid in the ratio of 50 is to 50 is to 15, and also toluene is to chloroform, ethanol can also be performed in the ratio of 40 is to 40 is to 10. Essential oil generally can be performed with toluene and ethyl acetate in the ratio of 93 is to 7. Ligands can be performed with 3 solvent systems, can be helpful for separating ligands. Chloroform is to methanol and water in 70 is to 30 is to 4. Chloroform and methanol in the ratio of 90 is to 10. And toluene and ethyl acetate in 70 is to 30. So these are some examples. Derivatization also done by some reagents like drag and draft for alkaloids, which gives very clear spots can be identified in red, brown zones are visible, and natural compounds like polyethylene glycol reagent, diphenoluric acid and amino acetyl esters 2 amino acetyl ester can be used for flavonoids. Intense yellow, orange and green fluorescent zones in UV nanometer, 360 nanometer, which we can see very clearly. Ninhydrin reagent can be used for amino acid peptides, amines and amino sugars. Yellow, brown or a pink and a violet visible spots can be seen. And there are some agents like iodine is produced iodine reaction possible for resulting oxidative products like indole, quinolone derivatives, thiols and all organic compounds. They will give dark brown or dark zones in UV 254 nanometer. And 10% ethanolic potassium alcoholic solution can also be used, 10% for anthraquinone derivatives, amodine, rheomodine. Red zones can be seen in the fluorescence of 360 nanometer in UV light. And if you see anthrones, aloe in there is cascara, which contains the constituents for example, these glycosides like anthraquin glycosides of cascaroids can be seen yellow zones in visible light and also yellow fluorescent zone in an very fluorescent zone in UV 360 nanometer. Coumarins, scopolamine, amblyophenol Amblyfuran is one of the fluorescent compound which you can say bright blue fluorescent can be seen in when you are UV light 360 nanometer when you are using 10% ethanolic potassium hydroxide. So remember about derivatization agent which can also be used for fixing these spots. Identification spot more clearly and documentation can be done. So you can use even vanillin sulfuric acid or anisaldehyde sulfuric acid can be used for bitter principle. It will give red brown, yellow brown, dark zones can be seen in visible also. And saponins it will give colored zones. They are not given any color. Different colors can be shown, different saponins. Usually yellowish, slightly orange. And essential oil, blue, brown, red zones can be seen by visible itself. So this is about the HPTLC. Anyhow, you listen to the class and understand and make it more useful for your practical oriented and do your research work. Thank you for listening.